I will pass out your exams in just a second, but first things first, I wanted to address some grade stuff that just got posted. After each exam, we've done a post-exam 1, post-exam 2 grade. So that's where I calculated what your grade would be in the class, okay, what I think your letter grade turns into. We do now have a post-exam 3 grade, but this one's a little bit different. Post-exam 3 grade, the amount of stuff left in the semester is now relatively small. Okay, so what I did within the post-exam 3 grade is said, you know what, the only thing really left that's a large grade changer is your final exam. So I now run the calculation for a final letter grade in the class, where I take your exam 1, 2, 3 grades, average them, and turn that into a score on the final. Okay, so if you maintain your current performance, so if you've been doing all the play posits, doing all the paper homework, all that, you maintain all of that, and you maintain your exam performance on the final, okay, as an average score, that is now your post-exam 3 grade. So that's what this is. This roughly equates to your final letter grade. Okay. What I want you to be aware of within that context is some of kind of those assumptions. So that first assumption is that your final score, no, we're calling out a 70, we'll talk about that in a second. That average final prediction is the average. So that's what I'm assuming you're getting on exam 1, 2, 3 as an average, and I turn that into a final exam score. That's what that final exam average final prediction is. Okay, it's out of 70. Why? The target most semesters when I look at a final exam is 70 questions. Yours might be a little bit smaller than 70, so you would have to adjust, and I might be able to adjust later when I spend a little bit more time looking at structuring how long I want that final exam to be. Okay, but 70 questions is kind of the national standard for the time span that we've got. Okay, so that score in Canvas under average final prediction is the amount of questions you are expected to get right. Okay, if you get that, that's your average exam grade, and you would expect to get your final letter grade. That's the post-exam 3 grade. That's your predicted final letter grade. So if you hit the average final number questions right, boom, you've got exam 3 grade. Kind of makes sense? Okay. Yes. After that, I think students generally want to know what could they do to do better in the class. That's this advanced final prediction. So what I went through and said, is it possible for you to advance a letter grade? If it is possible, what is the score that you would have to get on the final? Because remember, if your final is higher than your lowest exam, it replaces the lowest exam. Okay, so the final can be both a bonus in and of itself, or not a bonus, but an increase in your grade in and of itself, but it can also doubly affect your semester performance. So I went through and ran that calculation for an advanced final prediction. Okay, so the number it spits out there, if you get that number of questions right out of 70, and we're assuming 70 questions here at this point, okay, then what you get is one letter grade higher than that final letter grade. Okay, so let's go through and say your final letter grade comes in at a C. Your average final prediction says you get, I don't know, 35 questions right. And to advance a letter grade, you need 37 questions right. What does that mean to you?
You would want to try to get 37 if you
Okay.
want a higher grade.
I mean, I would take it a step further. So to me, what that means is I'm damn close to getting a higher letter grade. Okay, I'm talking 2 questions difference. Okay, out of 70 to get a B instead of a C. That means what I need to do now is burn the midnight oil and do whatever I didn't do in the past to do better so that I can ensure I get a higher letter grade at the end of the semester. Let's switch up a number. What does that mean to you now?
Probably not going to get a higher letter grade.
Okay. I know you all have other classes and other parts of your life that you have to worry about. Okay. So if you see that system where you're expected to get a 35 out of 70 and to advance a letter grade, you need a 60 out of 70. That's a really big jump. Okay. I'm not saying you shouldn't try to make that jump, but I want you to be aware of what you have to do to make that jump. That's a whole lot more work you have to put in on your end to ensure that you can make that jump. Does that make sense? Okay. So actually, we'll leave it at that 60. So you see that 60 and you're like, well, dang, that's a big jump. I don't think I have the time or bandwidth to be able to make a jump from a C to a B. Okay. But now your question changes. Now you don't care about going up, you care about passing, not going down. So what you might want to consider is, what do you need to maintain your letter grade? That's what that maintain final prediction is. Okay? So again, we'll play around with some numbers here. To maintain your final letter grade, you need 20 questions right. Okay? You get 20 questions right, you are guaranteed to achieve that final letter grade. You're currently expected to get 35. Okay? With the efforts that you have been putting in, you are predicted to get a 35. What does that mean? Okay. You could look at it that way. Just continue doing what you're doing. Okay. That's a 15 question buffer. So if you just continue what you're doing, you should be good. Okay. Do you have other classes that you feel are more important to pass? That you think you're equally in trouble in?
Or more in trouble in.
Or more in trouble in? You could go through and now shift focus to look at those, hoping that we shift, that shift isn't too bad of a loss for you here. You've got enough buffer. Does that make sense? What does it mean now?
You're still going to have to put in some effort to maintain.
You're now looking at a 1 question buffer. You're going to have to maintain. Okay? So where, Lindsay, you were like, we could just maintain what we were doing before. Would argue you could. It's not a wrong decision, but you didn't have to put in that much effort because you had some wiggle room. Do you have some wiggle room now? No. If anything, in this point, if you wanted that C, it's not a question of just maintaining your effort. You should actually be striving even more to ensure you clear that buffer line. Does that make sense? Okay. All of this is information to help guide you in what you need to do both for this class and to potentially what you need to do for other classes. Okay? Everybody's number is different. Okay? So look at your numbers, and if you struggle to figure out what those numbers mean, that's okay. Talk to me, and we can work through them. You should be seeing whole numbers for these two, because I was only really putting in, usually it's by sets of 5. Okay? So I'll check it at 60, and if 60 didn't do what I wanted it to do, I'll do 65. Okay? The average value, you'll probably see a decimal because it's an average of 3 actual exam scores. So you'll probably see some decimal value. Okay? What you decide to do with that decimal is kind of up to you. For me, kind of panic and always trying to hedge my bets, I would round up. Okay? And say that my average, I need to be scoring a higher number to maintain that, so that if I fudge a little bit, I've got some buffer room. Okay? So these numbers are here to help guide how you should be deciding, or how much effort you need to be deciding to put into the final for the class. Kind of make sense?
Thanks for doing that.
Questions?
Are you gonna do, like, kinda how we have like the week 5, week 6, the practice questions for homework? Are we gonna have that for like the final that includes everything, or should we just go back and use those previous ones for both? Because I know you said we're still learning some new stuff, but then the final will be on everything.
I'm going to come back to that.
Okay.
There's something else I want to say for sure on this, and I thought there was something else. I think the obvious stuff. Do you have any questions about what we just walked through as far as this went? If you came in a little bit late, it's the recording. You're looking at the first 10 minutes. Play it on double speed. Okay, the last thing I want to point out, before I get to your questions, Sydney, is this thing right here. This is actually new this semester. Well, this is the first time I'm trying it. I don't know how well it's going to work, but we'll see. But with small enough class, it was possible. You have paper homework, you have play posits, and then you have the Unit 2 quizzes that were all on Canvas. Okay, those Unit 2 quizzes, I heard from a couple of them, oh, it's only a point, I don't have to worry about it. You're right, it is only a point. Okay, but that point is part of 10 components that add to a 10% in your grade. Okay, that 1 point translates to about a percentage point in a letter grade change. So that 1 point isn't 1 point in the grand scheme like a point on the exam. It's a percentage point in the class. Okay? Do you like leaving questions blank on an exam? Do not leave those blank. Okay? Those need to be completed. Okay? I've already heard, but I've completed them all my attempts already. And I have said multiple times, you must ask to take it again. That's fine. But you have to ask. Because what's going to happen is I'm going to open it up and look at it to see if I can figure out why you're getting it wrong, so that we can prevent you getting it wrong on an exam. Okay? That's all it is. Then you can go in and do it. Okay? So if we look at those percentage left uncompleted, right, I would say the majority of the class is doing okay, and a percent of their grade that they are neglecting or deciding that they don't want is about 1% of your grade. Okay, I get that. That's not that big of a loss. Okay? There's a couple people that are sitting in the 5 and 10%. The 10% is a big, big problem to me. You're effectively saying you have no desire to get an A, and you're not even going to try to get there. Those are free points that you are giving up. Please stop. Please stop. And if you have questions about it, let me know so that I can help you fix that. Okay? One of the things that is missing from that is the Unit 1 things. Where are those? Okay, these Unit 1 quiz things. And I know we're looking at it in a format that you can't see these, okay? But these Unit 1 things, I can't tally into this quite as easily, because what did we use those Unit 1 quizzes for?
To earn points back on the first exam.
To increase your score on exam 1. By leaving these blank, you're keeping exam 1 score low. You're hurting your grade there also. I can't quantify very easily how many points you're losing that way. Okay, but you are still losing percentage points to your grade. Okay? So please look at that percentage left uncompleted, okay, within your grade book. It's annoying. I don't like how Canvas runs the grade book. It's just how it is. But look for that thing. And if your number is a number that you're like, ooh, I can't live with that, fix it. Okay? The two biggest places are the quiz 2s, or the Unit 2 quizzes, and I'll show you where you can find them, I'll show you where you can find those. Those are less easy to find. Okay? And the paper homeworks. Okay? If you haven't gotten perfect scores in the paper homeworks, that's okay. You can submit late. Okay? And every time I grade it, I have a comment saying, this is what you need to do to get the missed points back. Get the missed points back. Okay? They're there for you to practice so that you can be successful when it's a high stakes environment. So spend the time to get those points maxed out. That means I got to do 80 practice questions. Okay, is your exam score, are you happy with it? And if your answer to that question isn't a flippin' screaming yes, because I got a perfect exam score, then you aren't happy with it. You need more practice. That's what an imperfect exam score means. Okay? So do more practice, and now get credit for having done that practice. That's why it's there. Make sense? Okay. I'm trying to hold on to your question in my head, Sydney. The Unit 1 stuff is here. So it is in the modules right up at the very top. Okay, that's what they're there for. I kept them there because some people still have not completed them. Okay, I don't think anybody has completed them perfectly. Okay, you may have decided you're perfect enough. I'm still going to yell at you because you're not perfect. Okay, you can just choose to ignore me. That's fine. Okay. The Unit 2 stuff is much, much trickier because the Unit 2 stuff was embedded as homework within Unit 2. So if we look, Unit 1 ended week 5. So Unit 2, week 6. Right at the end, you've got a whole bunch of those quizzes put there. Okay, week 7, you have several of them. Maybe week 8. Yeah. So I think that's it. So here's a vote. Would you like me to make the Unit 2 stuff in its own module back up at the top? Sorry for the wicked scrolling. Should I do that? Okay, I'll do that. So I'll build that in so you can see that Unit 2 stuff there. Okay. Okay, so plan for the rest of the semester. To Sydney's question, hopefully I get it right. Okay, what you're asking for is more practice questions for the last unit. So we get 2 documents within the week 14 module, old review and a lec22, and then last part, .docx. Both of those are your reviews. I've only opened and reviewed recently the old review and a lec22. I apologize, last week I got sick and did 0. It was very non-functional at the end of last week. I guess I can open this one, see what it looks like. Last part I'm going to hope is actually all the nucleophile addition. Yes. Yes. So, to, I believe, answering your question, those 2 documents are our practice for the rest of the semester. Does
Does that include like that's just for the last of the semester, and then we should use the old
Oh, yeah, that was the
for
other half.
like final?
The old review Analec edition does have old content in it.
Okay.
Poorly edited, so there's actually duplication within the document itself
Okay.
as I've been reviewing it. I don't know that it's just a copy and paste of the old documents.
Okay. So still beneficial to use those other weeks? Okay.
I don't think it should hurt. You can go back and look at them.
Okay.
I don't know why I know why I'm missing the week 15. We'll talk about that in a second too, maybe. And yeah, they're still showing up in the week 16 also. So they are consistent in both. I'm going to make sure they're indented because I like having them indented. I think it helps pull them away from the rest of it. So I think that addresses your question, right, Cindy? Okay.
Yeah.
Anybody else have questions? Okay. I'll pause the video real quickly. Questions? To Sydney's point about review, looking back for old things to review to make sure you've got the old stuff down solid for when it shows up on the final, because it will. I actually thought of a step better than going back and look at the old units. You can absolutely do that. Where should you look first?
Your exams.
Look at your exams. Why are you getting questions wrong? Okay. The why can be a really hard question to answer. Okay? Because you don't necessarily know why you are wrong or why you chose the wrong answer unless you really sit down with someone and they push you to figure out why you chose the answer you chose. Okay? I'm more than happy to do that with anybody. You just got to sit down in office hours and we'll go through. We'll look at each piece and be like, okay, why did you pick this answer? Okay? And one of the first things that I will do when I look at it is be like, where's the work that you wrote on your exam to lead you to this answer? Okay? And that is probably the most telling question for everybody taking an exam, period. Because how much work did you all write down? If you just had to guess.
Probably not enough.
I would argue it's non-existent, okay, in the vast majority of cases. So if we look at it on average, there's nothing written for work, okay? That means you're attempting to do everything in your head. I don't think I've used this story in this class, but I use it in other classes, so let's bring it in, okay? Would you like it if I could just beam into your head and hear what you were thinking?
No.
Okay? So you don't want me going into your brain, and yet where are you trying to solve all of your work? In that very same sacred spot that you don't want anybody in. That's a problem. Don't do work in a scary space. Okay? I'll wear a clown tie if you need to make me less scary. I'll hide behind the desk. Okay? Get your work out onto paper where you can actually start to think about it and stop your brain looping things. Okay? It's a hard thing to overcome. Try your best. Okay? So what do we want to look at? Anything at this point?
One quick question. The percentage left uncompleted, that's, I know what it is, but if we have like the full score, does that mean we have a lot left uncompleted? Or like, what does that big decimal mean?
A double tap.
Cause like for me, I'm not missing anything, but there's the quizzes that I don't have the 1 full point on. And I
Yes.
just maxed out my attempts and I just need to ask for more attempts. But like, what should I want that to be down to?
So the percentage left uncompleted, I think should be 0,
Should
ideally.
be 0 out of whatever decimal.
And yeah, because the points is 0, it holds 0 value. Theoretically, what it's reporting as is a decimal number through, and I don't think we got higher than 10.
Okay.
Okay, so you're saying some numerical value with any decimal range after it. That's just an artifact of the calculation.
Okay.
So when I run these calculations, I'm not trying to nitpick and weed through them. These are, and even with the grade calculations, they're very, very quickly done, and they're all done anonymously as well. So I'm trying to minimize any kind of secondary kind of contamination of that data. So if you look at that number and you're like, oh, it's 0.234, okay? That means your highest grade in the class, if you get everything else perfectly done, would be, 99.692. That would be your high grade. Are you okay with that being your highest grade in the class? Yeah? Okay. Then that's fine. Okay? If it's 9.5, let's pick an easier number. Are you okay with the highest grade you could possibly get being a 90.5? Right? That means getting perfect on the exams. You perfect the exams, the highest you could grade in the class you could get was a 90.5. That, to me, if I got perfect on the exams, I'd be pretty pissed if all I could get out of it, though officially it's really how it comes out, would be a low A. Like that seems kind of counterproductive. Right? So this percentage left uncompleted is those kind of, they aren't attendance points, they aren't free points because you have to work for them, but they're points that you should be maximizing so that you can minimize the loss or the effects of the loss in exams, because the exams will be a loss. So look at that number and decide if it's okay to you. And so if you want specifics, we can go through specifics, but that's going to have to be more personal or private, I guess I should say, because we're now, it's not technically your grade, but it has grade information in it. So I would prefer to not talk about that loudly in a recorded environment or a publicly recorded environment. You can record whatever you want in private. I'm fine with that, but that's your own purposes. Does that make sense? And I would argue there are a couple people, and you might be one of them, where the number is low enough that, yeah, it's probably not worth doing any extra effort for, and just focus on everything else. But there were a couple numbers that were high enough that it needed to be called out so that you were aware of it, because I'm not sure students were aware of it. Make sense? Next question. So, question A Provide the missing reagents to complete the following transformation. Provide any information that will allow for partial credit. Okay, so a couple things I'll point out. Number one, we're clearly addressing here that you need to give me something to allow for partial credit. You give me something, I can now start to work towards points. You give me nothing, I can't work on anything. Okay? The next part is trying to figure out what the answer is. Okay? And that becomes really challenging because most students, when they look at a question like this, immediately try to do what? Come up with the answer. Okay? That's not going to work. Y'all are moving into fields where there isn't an answer. There's a process that you would need to follow to get someone to being a better version of where they're currently at. Okay? So what you've got to go through and do is work through that process. By the time you work through that process, maybe you have an answer, but you've got to work through that process. Okay? So we're trying to figure out what chemicals were used to make this change. Things bugging me a little bit. Maybe what I should do first would be to identify what actually changed. So what did I start with? Okay. So I've got 3 carbons. We do a change. Okay, that's what our arrow is supposed to represent. What do we end with?
More carbons.
More carbons. Okay. Did we make this problem easier or harder? Or said maybe a different way. What do you think the change was that we went through? If I start with 3 carbons and I end with more carbons.
You added
I added what?
carbons.
So this change has to involve adding carbons. How many carbons should I be adding?
3.
How do I know 3? I start with 3 and I end with just more carbons.
Well, you had 3, and then you had your original 3, and then you have 3 more.
So what I'm pushing to is that our initial statement of, oh, we ended with just more carbons,
Oh,
was
more
not
carbons.
exact enough for us to actually build anything on. So we could go through and say that we ended with 6 carbons. 3, 4, 5, 6. Is that what you said?
I think so.
Okay, I like the I think. What is I think? Why do you say I think?
Because I didn't make it very far in this problem, so
Okay.
that's as far as I got.
How do you know they're carbons?
Because it's a chain, that's how we see them.
Okay, so there's an interpretation when you're looking at these drawings. Each of the points within a structure is a carbon. Okay? Except I don't really see any points in this first one except maybe where it starts and where it ends. Wouldn't that only be 2 carbons? No. Why?
Because there's like bonds.
That extra point in the middle. Okay? Why is it shown as a straight line? Why is it not shown zigzag so I could see that point better.
At least that's the shape.
Why is that the shape? I love that. What dictates the shape, particularly about that carbon?
Isn't it a Lewis structure? It just seems like a Lewis structure. It looks like this triple bond and what's on it. It seems like that's how it works.
True, but as a Lewis structure, that is also a Lewis structure. How do I know it should be drawn as above and not as the one underneath?
Tell me. Geometry.
We now start to move into all of that stuff from Unit 1, explaining the shape of the molecules. Why does the shape come into about? It's electron repulsion. Right? And we can look at defining those shapes based off the electron groups around an individual atom. All of that stuff is going to show up where?
Here.
The final exam. Right? That should all be review stuff. Right? That you should be able to pull up pretty quickly because you had to use that to answer the questions I've been pushing on you. Right, so cool, you've got 3 carbons. So what does that mean? Well, we could go back to our starting thing or our product and be like, the product is actually the 3 red carbons, and I just need to add 3 more carbons. Right? Why not?
Because you need the electrons to form the bonds.
Oh, okay. So that when we look at this, what you're actually saying is it's not just these loose carbons, they're actually connected to each other. Okay? And that what you're talking about is the connection that changed. Okay? But to know the connection that changed, what must I define in my starting material? The original connections. What connections do I want in my final carbons? Like, why do I want sigma bonds?
Because that's what is shown above.
If we use the context within the question and looking at those, we know those were also sigma bonds. Right? So if we're looking at this thing happening, we're looking at that connection. Which means the thing that we're adding, we need to be adding those connected to each other. And of those, we really only care about how many of those carbons.
That first one that connects to it.
I care about what's happening out here. Because that area and this area have to somehow overlap to make our final connection here. And you're right. That connection has to do with electrons. So the question becomes, where do I get the electrons to make my final product? Did those electrons come from, I guess we'll call it the purple box, or did they come from the blue box? Or do I get 1 electron each? How many times have you seen 1 electron each work? How many times have we talked about 1 electron? We haven't. Okay. So do you think that's a good path? Okay. So we're looking at the electrons being paired. So what happens if I said, I don't know, I'm going to pair the electrons in the blue box? So we'll look at option 1. They're going to be paired. If the electrons were paired on that carbon, what would that mean about the carbon?
It was positive.
Does that carbon look positive right now? Actually, we'll do it this way. that carbon positive?
It's positive one. Well, are we assuming hydrogens to complete it?
I don't know. Are you assuming hydrogens to complete this?
Is that completing its octet, or is it just as it is?
So, and that's an interesting and valid question behind this. Okay, if we look at the blue stuff, what is the blue stuff that we're putting into this? This is coming from the change. What was the change? Yeah. What are you trying to solve in this question?
How did it connect?
Which means, in that blue stuff, you have to define it, not me. You have to define what it is. So if you want to put hydrogens in there, you have to make sure you're careful about specifying those hydrogens. Because at this point, none of those carbons have their octets. So they could all be wickedly reacted. Okay? Do we have information about the question about whether they have hydrogens or not? So let's look at this carbon. Call that first red carbon. That came from up here. Does the question tell me how many hydrogens are connected to that carbon?
No, we would assume like these two the information that we have is complete, met,
That's
satisfied, happy.
where we have to be more kind of explicit within it. Okay? It's not an assumption. Okay? It's part of the language. We have defined, since the beginning of the semester, that hydrogens are implied. Okay? So for that carbon, that red dot carbon at the very, very, very beginning has 3 hydrogens connected to it. We know that is true.
So then we would know that the change, what goes in the boxes, or at least one of the box, it has to be something that's going to, since we're working with carbon and they have their implied hydrogens, take away those hydrogens.
How many hydrogens are on, let's see, can I get my screen to do what I want it to do? That carbon.
3.
3. Where's that carbon and what we have decided is our change?
At the end.
It's over here. Whoop, lost connection. Which means, should I just be writing C?
Could do CH3.
How about the carbon to the left of it?
It has 2.
How about the carbon to the left of it?
Has 2 because we know it's going to bond to the other carbon.
All of that information has been implied within the question. That is given information. The only thing you are modifying is that box saying I want a lone pair there. Okay. If we put a lone pair there, what happens to that carbon?
Neutral.
Turns into C.
Oh, wait, one. It's positive. It's negative. 3.
So let's walk through the answers that are possible. Okay? Because interesting, all 3 answers have been provided. It's neutral, it's positive, and it's negative.
It's negative.
All 3 of those answers should have been immediately, or one of them should have been immediately said from the very get-go, because of all of this information being Unit 1 material that has to be pulled back and used. And so what's happening is you aren't pulling back that content and you're trying to memorize your way out. For a problem like this, that's really hard to do. So you have to be able to apply and walk your way through using that old content so that you can build larger things quicker and faster. Carbon has 4 valence electrons. Minus 3 bonds, minus 2 non-bonding electrons gets us a charge of -1. That carbon would be negatively charged. If that carbon is negatively charged, what must the red carbon be?
Positive.
Awesome. That red carbon must be positively charged. Okay. All we've addressed is this is a possibility. Okay. Did the red carbon start positive?
No,
Ooh, why not?
because again, we know, I'm assuming
Thank
we
you.
know it's all met and happy and balanced and stable. And then what's in the boxes is going to take away.
How is it met and happy and stable? Because right now I only see 6 electrons around it.
The implied hydrogens.
There's an implied hydrogen. What changed?
Someone took away that hydrogen.
Ooh,
Well, the hydrogen
You mean
gave its electrons.
if we had recognized the change that not only are we adding carbons, that we are also removing a hydrogen,
Gave positive hydrogen.
we might have some more context behind this. Okay, so there's an interesting thing. You're saying the hydrogen has to be removed as a positive. If the hydrogen's removed as a positive, what must the carbon be? If this hydrogen disappears as a positive, this carbon must be,
It's electrons, because then that would make it negative.
that carbon would be negative. We just said we wanted the carbon to be positive. So what would this hydrogen have to do?
Take its electrons.
Take the electrons away from carbon. Can hydrogen do that? No. What does that mean about our first attempt to solve this?
We were wrong.
So what do we do when we're wrong?
Try again.
You try again. Okay? I would argue in a testing environment, when you do this and you go, oh shit, I'm wrong, what should you do?
You move on to the
You move on.
on.
Have you left a bunch of work here? Yeah. Okay. Is it the answer? No. But has it shown a thought process behind how you should navigate this question? Yes. Okay. How many points would I give this? Probably 3 out of 4. Okay. If I graded everybody's and everybody's was blank and this was one answer that was provided, I'd probably actually give this 4 out of 4. Okay? Officially, what I would want to see also is an acknowledgement that you know it's wrong. You attempted a logical process, the same process we've been working throughout the semester, and you acknowledge it's wrong. You've spent a bunch of time on it. You know you're wrong. To potentially fix it, you've got to make a whole bunch of changes. Are those changes going to take time?
Yeah.
Yeah. Have you looked at the rest of the exam yet? No? Move on. Okay? Sometimes you just have to be able to step away. Okay? But cool, you've looked at the rest of the exam, you've come back, and now you've got this work. We know this answer was wrong. What could we do in an attempt to change it?
Well, this was wrong in terms of like the hydrogen leaving, but would it still be positive and negative? Because we know we have CH3.
It has to be positive and negative because we can't do single dots.
Yeah.
Which means I do have to remove that hydrogen. And if I remove that hydrogen, what must the carbon be?
Negative. So then the other one, the other carbon, CH3, that's adding on, that's going to be your positive carbon. So then we know something in the box is going to have to make that carbon positive, and then it's going to make that carbon negative, because it's going to take away the hydrogen.
Cool. So we've got 2 things going on and we have to address both of those things. Okay, one, I got to get rid of that hydrogen. I can't make the connection until that hydrogen is gone. So my first step should be get rid of the hydrogen. Well, what is that molecule acting as if it gives up that hydrogen?
Proton. Wait, the hydrogen becomes the proton?
The hydrogen would be a proton, yes. What did that molecule act as if it gave up a hydrogen? What would I react an acid with?
A base.
It says reagent, so we should probably take it a step further. Give me a base. Boom, boom, boom. Sorry. Bad joke. Bad time. Read the room. Hydrogen chloride. Is hydrogen chloride a base? No, this is our acid. Okay. Throughout the semester, I've been asking, do you know, give me an example of a strong acid, give me an example of a strong base. Those have been repeated questions. If we have the answer to that question nailed down, when I say I need a base, you go, oh yeah, we've been using that throughout the entire semester. We could use that. Sodium hydroxide. We'll come back to that in a second. But we can say sodium hydroxide, base, cool. That gets me the negative, fantastic. Step 2, I would need to bring in this positive. Okay? Could I just draw this thing as my final answer?
No.
Why not?
Because it wouldn't just be positive by itself, something has to make it positive.
So you're saying things can't be positive on their own?
Well, yeah, they can, but it wouldn't be stable in the second box.
Okay, so that wouldn't be a stable thing to put in there. Okay, one of the biggest reasons for that is that it's charged. Okay, we can push on it a little bit further. It's a positive charge on what kind of a carbon? Is it a tertiary carbon? How do we classify the carbon? So our classification goes back to where the positive charge is located. It's located on that carbon. How many carbons are connected to that carbon?
Just one.
Just one. That's a primary carbocation. And primary carbocation stable? No, that's why you should not draw it up in the box. You've acknowledged the chemistry that needs to happen, right? But it can't just exist like that. It's not properly stable. So I need to put something here or connect it to something such that the carbon will give its electrons up to whatever that thing is. Okay? So we could try something like an oxygen. What's the common bonding pattern for oxygen? It is a polar covalent bond, yes, but the common bonding pattern, carbon common bonding pattern is it has to have 4 bonds.
Oh, it's usually double bonded. By bond?
Do I have 2 bonds to that oxygen right now?
Just one.
I just have 1, which means
Sigma.
it is a sigma, but the common bonding pattern is 2. I only have 1. I have to fix that. How do I fix that? I have to add another bond. What do I want to put on the other end of that bond?
You want to put,
Right? There's a suggestion of a hydrogen. What can you tell me about that particular bond?
it's going to want to take that.
It's a polar covalent. Okay, it's not a strong base because it's connected to a non-metal. So if that's where you're going to say, be careful with that. That is a protic hydrogen. Protic hydrogens are susceptible to acid-base reactions, so reacting with strong bases. What do we have in step 1?
Like box one, a base.
A base, which means more than likely what's going to happen is our base is going to come through, remove that hydrogen, and make this oxygen negatively charged. If that oxygen is negatively charged, what happens to the strength of that black bond?
It's gonna pull the electrons.
If it pulls the electrons, what is oxygen acting as?
A base, an acid, strong electronegative molecule.
Be acting as a leaving group
Oh,
because it leaves behind the carbon structure. Is that a good leaving group?
no.
That's a bad leaving group. What does that suggest about using O bonded to H?
Maybe not.
Maybe not a good idea. But maybe if I bring in that language of what it needs to do, instead of focusing on the atom and saying, what does that atom need to be able to do? This atom, whatever it is, needs to be able to take the electrons away from the carbon, meaning it needs to act as a leaving group. What is a good example of a leaving group atom?
Bromine.
You mean all of the halides that we've been working with for this past unit? Yeah. Yeah, I can make the X a bromine.
So that would be BrCH3,
CH what?
right?
Look at the piece.
Sorry, CH2, CH2, CH3.
Now we have a functional system that includes the pieces behind it. Okay. All too commonly, people just want to jump to what the answer is. I have every expectation you ask any faculty member or really any tutor what the answer is, none of this work is going to show up. The only thing that will show up would be a step 1. They'd probably give you NaH if you're talking to tutors. If you talk to faculty, you'd probably get NaH2. And that is all they would write. Because what is that? That's the correct answer. You don't need to show any work. Why don't they not need to show any work? Where did they do all of this work that we just drew out?
In their head.
In their head, because they've had experience with it. It's in a show your work system because what I want you to do is write that work down to prove that you can get there. Okay? Why NaH2 or NaH instead of sodium hydroxide? Well, in step 1, that's an acid-base reaction. Acid-base reactions can be dependent on pKa's. Guess what? Sodium hydroxide is not a strong enough base to deprotonate the alkyne. You need a stronger base. That's why NaNH2 is more appropriate. That's why NaH is equally appropriate, though it's significantly stronger and can cause secondary problems. Right? But what you're pushing through is trying to find your positives, your negatives, okay, and establishing them. And in this, we establish them incorrectly at first. It's not a problem to do it incorrectly in a low-stress environment. It's only a problem to do it in a high-stress environment, which is why you should be doing practice to look for these pieces. Was this practice available to you? This exact question was actually in the practice set. Okay.
From week 4, 5, and 6?
I don't remember which week it was in. I don't know which one. I'd have to dig it up.
I feel like I've seen it more recently in the paper on like practice questions.
And I know there's lots of practice questions. Yeah. So when you do the practice questions, you should be like, oh, I get this one. If you get it, look at the next question. Does the next question look like it's following the same pattern? Well, if you got it, don't keep doing it. Okay? Find a different questions type. Okay? Because you're going to see all sorts of different question types all over the place. So you have to test yourself in each of those different systems. Is it hard? This is definitely a hard question. It's also only worth 4 points. So you could leave it blank because you're like, it's only 4 points. It's not worth my time to figure it out because I have no clue. That's fine. But identifying those changes is pretty critical to you being able to navigate it. Within those changes, you have to acknowledge some of the assumptions you're either making or not making. Okay? And when I went through and did this, I initially left the hydrogens out. Why? Because you weren't explicit behind it. And as soon as we started to get explicit, that's when we noticed that we also had to remove that hydrogen. And as soon as we knew we had to remove the hydrogen, that changed the whole dynamic of where our positives and negatives could be. If we had recognized that hydrogen is changing, that shifts the whole problem out of the wrong path. If you remember back on exam 1, there was a question that everybody gets wrong, and everybody goes, oh, this is dumb, why should we get this question wrong? You're just having us count hydrogens. Because if I don't have you look for those hydrogens, and ideally recognize that mistake early on, it haunts you, and it becomes even more problematic further down the road. So you've got to look for those pieces. Questions about what's up there?
So on this, if, say we didn't write like base or NA, OH, BR, we didn't write all that, but we just wrote like base, leaving group, bonded to.
You should have been getting some partial credit.
Okay.
Yeah. And if you want to come down and be like, well, I don't think you gave me enough partial credit, you can bring it to me and I can take a look at it.
Okay.
But yeah, the way these, just to give you an idea on the way short answer gets graded, is I don't grade an individual student. I grade the first page, then I grade the first page for the next student, the first page for the next student, the first page for the next student. And as I go through, if I feel there's inconsistencies within that grading, I'll go back and change scores around so that the scores are relatively consistent. Then I go to the next page, do the same thing. Grade all of the next page together. Try to establish a key beforehand. Keys rarely catch all of the possible ways that you can write things that I go, I'll give you a point for. Okay. With 5 minutes left, I'm going to take over. Come on. The rest of this semester is really going to focus on kind of, I'm going to say we'll call it 2 reactions. Additions, we're going to see a significant portion on additions, and we're also going to have to go through and do another thing on substitutions. The thing on substitutions is a little bit weird, because while it's called a substitution, it's really following an addition.
Love that.
Yeah. Okay. So we'll go through and look at those. It fits the substitution class of reaction. It doesn't fit any of the substitution mechanisms. Okay. So the first addition that we'll look at is electrophile additions. So if we're looking at an electrophile, that needs to be something that is positively charged, because an electrophile accepts electrons. Okay? So something that accepts electrons typically would be positively charged. It can be partially positive, okay? But we're looking at something that's positive. right? And if we're talking about positives and we're talking about additions, well, the addition is a loss of a pi bond. So we could now bring in a pi bond near our electrophile. Well, what does the pi bond supply? The pi bond supplies electrons. The sigma bond stays constant in this, and so that pi bond will act as a nucleophile with our positive. What's the necessary result of this? The pi bond disappears, and I now have a new bond. We're now using the positive not as its charge, but as its label. I don't like that. Here's the label, E for electrophile. Okay. Where did the pi bond come from? The pi bond is the sharing of a pair of electrons between two carbons. Note, I drew the bond to E on the left-hand side. Why did I not draw it on the right-hand side? Is there a difference?
No.
There is no difference. Okay? I would need some more information within this to figure out that difference. We'll layer that more information in a second. That pi bond came from electrons being shared between two carbons. We took both of those electrons in the pi bond and we put both of them into the new sigma bond between the carbon and the electrophile. What does that mean about our remaining carbon? What happened to it? It's now missing an electron. It is positively charged. Since it is now positively charged, it needs to find electrons somewhere else in the environment. Okay? And if we're talking about a thing that is now going to supply electrons to that positive charge, what must that thing be called? Yeah, that would be a nucleophile. So if we're looking at our overall electrophile addition, we started off by adding an electrophile, but at the end, we're going to have to add a nucleophile also. Both of those pieces have to happen, but the order in which they happen become important, and that order is dictated based off of the type of mechanism we're looking at, electrophile addition. Okay, are there other things that we're going to have to be concerned about? Okay, well, that nucleophile could come in from the top or the bottom, which means is stereochemistry potentially an issue? Yes. Okay. We're talking about a pi bond. Are all pi bonds the same? No, they could be different. Okay. So what pi bonds are going to be more likely to react with positives than others? So we would have to do a rundown of all of our pi bonds. It turns out that the only pi bond that really works for this are our non-polar pi bonds. Okay, which means atom 1 and 2 must be a non-polar covalent bond. So I have to use that logic system to explain that. What's that going to result in? Alkene and alkyne functional groups are what we're talking about when we look at electrophile additions. All the other secondary kind of logistics behind the nuances of what electrophile, what nucleophile, what orientation are now all looking at very gory details of the mechanisms involved in each of these. What we've now kind of moved away from, though, mostly due to time, is that we no longer have the ability to look at all the gory details, and instead, we have to memorize. Right? Our structure was designed so that we didn't have to memorize, because we were going to fall back on using our content knowledge to help us build forwards. That content knowledge has some issues, which now means we move into a system where we can't really explain what's happening and we have to accept. And if we look at our alkene addition summary, this is now effectively what's called a spider diagram showing all of the alkene addition reactions that we're now responsible for. Some of them won't show up. We'll talk about kind of that type of reaction a little bit, like that one disappears. Oof, was that the only one? That was the only one. Okay. But what we could go through and do is look for patterns of what's happening within these reactions. Once we've established those patterns, we could start to group their reactivity. All of those groupings of reactivities are what's happening in the PlayPosit videos when we look at electrophile additions. Those groupings are relying on background knowledge to help build these things forward. That background knowledge is stuff that has been shared with you. Okay? If we go, well, that's not that bad, there's also this. Okay? Where we look at even more reagents and reactions. Okay? And then we'd start to move into the actual PlayPosits that are now talking through these. On Wednesday, what I would like to do, I remember this all right. Yep. Because we look, the next big thing is nucleophile addition and elimination, and note it says polar pi bonds. On Wednesday, what I would like to do would be to go in and look at the old review and electrophile addition and be like, how does this manifest for us? So what I would expect you to come prepared with is having watched those PlayPosit videos and being ready to go to look at these questions within this document, within the context of, at very least, this awful spider diagram. And where it's going to come into play is, how do we match what's happening within this to what's happening within this document? And if you're curious about where in this document that we're going to be looking at the end, because that's where all the addition stuff happens. So if we look here, does this show up here? And it does. But there's certain things that you have to be aware of and thinking about as we navigate that. And that's one of the things that I would like to be talking about instead of looking at the details of the reactions. We'll talk through the details of those reactions as we go also. Okay? But the PlayPosit stuff, that's stuff to provide the hows and the whys. We'll move forward with the whats for the rest of the semester. Kind of make sense? Okay.